Hi, in previous video, we explained the basic elementary continuous time signals. In this video, we are going to do the discrete time version. And it's very similar to the continuous time signals, except these signals are expressed as sequences or discrete values. Well, let's just start with the first one, how we express unit step signal. I'm talking now about the discrete version. Well, let's have the x-axis and y-axis. So that's x-axis and that's y-axis. Obviously, now we are not dealing with time, we are dealing with n. And n is integer, like it can take values 0, positive or negative 1, positive or negative 2, and so on. All right. And that's the amplitude or the sequence. We call it x of n. And we are going to use this square bracket and n instead of time. So if you are talking about the unit step, it means it's going to be 0 from negative infinity, 0, 0, 0. And once you get n is equal 0 here, then it jumped 1. And you can make this vertical line. That's m is equal 1, 1, 1, and so on. You can continue up to infinity. So how we express x of n? We agree that we are going to use the letter u for the unit step, u of n, and that will be equal to 1 when n is greater than or equal 0 and 0 otherwise. Remember, or you can, if you want to make it clear, when n less than 0. And you got to remember, n is always integer. You can say that u of n will be equal for n equal 0, 1, 2, 3, and so on. Only taken when n is equal 0 and all positive values only. That will be equal 1 and 0 otherwise. So that's the way you can express it. All right. So that's the unit steps discrete signal. What about the ramp? Unit ramp. And also sometimes, I mean, the continuous time signal you can write like that, and sometimes the discrete time signal you can write discrete time signal, or sometimes you can write sequence. Both are right. So you can write sequence or you can write discrete time signal. Both are equivalent. Anyway, how to make the ramp? The discrete ramp, that's n, and that's the vertical axis, x of n. To do the representation, it will be equal 0 from negative infinity, 0, 0, 0, 0, and here 0 when t is equal, n is equal 0. When n is equal 1, it will be equal 1. So it will be like that. When n equal 2, it will be equal 2. When n is equal 3, it's equal 3. When n is equal 4, is equal 4. Just very similar to the continuous, and so on. How you express that? You will say x of n. It doesn't look like x. X small of n is equal to n, but not for n greater than or equal 0, and 0 if n less than 0. When it's negative, take a negative value, it's 0. When take it 0 or positive value start to take the same value of n. So that's the unit ramp sequence. All right, let's move to the unit impulse signal. It's the same, right? It's the same, but how you express it? So unit impulse signal, or let us just write sequence. You have only one pulse, right? So you don't have any sequence, but I won't use the notation. If you have the horizontal axis n, you have the vertical axis x of n, so you have only one pulse, as you know, at n equals 0. Right? And we call it delta of n, like that. So delta of n is the same. The same thing will be like, doesn't have anything except only at n equals 0, and will be 0 when n not equal 0. There's nothing here. You can say, right? You can make it like 0's here, 0's here, everywhere, because only at n equal 1 is equal 0, 2 is equal 0, and so on. -1, -2, but only at n equals 0 it has the magnitude. All right. Let's just go now to the other one, which is unit rectangular pulse. Unit rectangular pulse is not actually going to be a pulse because it's discrete pulse, right? Or we can write sequence, as we agree. Again, let's have the vertical axis and the horizontal axis. That's n, and that's the x of n. And it's symmetric. So if let's say that it starts here to have value, it has 1, and this is called -2, -1, it has 1, at 0, at 1, at 2, and 0 after that, at 3 is equal 0, 4 equals 0, and -3 is equal 0, -4 is equal 0, and so on. So that's a unit rectangular sequence. All right. So how you write this? Well, in general, because maybe it starts from -2 in this example, and on the end at 2, but maybe it be from -3 to 3, -4 to 4. So you can say in general from -n to +n. All right, and the average is equal 1. How you write this one? You write x of n is equal rectangle. Instead of t, n, the variable here, n, divided by n, capital. So the width of this one, you have to be careful about the notation I'm going to use. N here represent 2. So in this example, you can write is a rectangle n over 2. Remember, how many pulses do you have? If you call L the number of total pulses, you got 1, that's 1, 2, 3, 4, 5. Because there is 1 here at n equals 0. So you got 2 before 0 and 2 pulses after 0, that's 4, and 1 at 0, that will make it 5. So always you remember the number of pulses will be equal to n plus 1. All right. So you got to be careful when you read the textbook which notation you're using. Some textbook they're using rectangular n over n capital, as I'm using here, and maybe In other textbook, you can write it like that. Just I want to make it familiar. We agree about that, but I mean, if you read another textbook, maybe if you found that n over 2n, all right? Some textbook they write this. And some they use the L, which is 2n plus 1. So you got, that's just to pay your attention, but we will use this notation in our semester. We're going to use n over n capital. So we know that's n, it's just the right or the left. Okay, great. So that's the unit rectangular sequence. The other one will be for the triangular, if you remember. So you have unit triangular sequence. We'll have to pay our attention to this one. So that's the horizontal axis n, and that's the vertical axis x of n. And let's just I'd like to do the continuous time version and then show you how to do the discrete. So let me use this. Let's say that w is equal 1, and let's say that is taken like. So you have here 1, 2, 3, 4. 1, 2, 3, 4. Has to be symmetric. So that's the continuous. So how do you do the discrete? Discrete, you will have one in the middle, right? And you have one here, one here, one here, and here will be 0. One here, one here, and here will be 0, right? So now we don't need this red line, it was just the guidance. So that's the triangular sequence. And when you look at it, that's in n equals 0, n equal 1, 2, 3, 4. Then it will be continue to be 0 like that. 0, negative 1, negative 2, negative 3, negative 4, negative 5, that's 0. All right. What about the amplitude? The maximum one here in the middle is equal 1. Just let's make dots here to make it. So how you express this triangle? It will be x of n. You remember the triangle will be like that. N over n. Where is n here in this example? That's your n. The first 0 here. That's the first 0 on the negative side. That's negative n. So in this particular example, that will be the triangular sequence n, because it's symmetric about n equals 0. And n in this case is equal 4. All right. And if you like to write mathematically, the expression will be 1 minus n over n. That's when n less than n. Let's see, what does it mean? Okay, when you look at it here, how you express it, if you look at this one, 1 minus n over n, in this example, n is equal 4, we said, all right? So if you put n equal 1, what you get? I'm sorry, put n equals 0. We'll start to find the one in the middle. If you put n equals 0, so you have 1 minus 0 is equal 1. That's right. The last one, n equal 4. So when you put here n is equal 4, so 4 over 4 is equal 1. 1 minus 1 is equal 0. That's right. So that's how you get the expression. By the one in the middle should be equal 1, and the one the last one in the triangle should be equal 0. All right. So it's always be, if the amplitude is equal 1, be 1 minus n over n plus 4. That's when. What about if you use the negative side? The negative side, if you have n greater than negative n, which is mean greater than negative 4, what do you think? Should write like that? Well, let's see. If you have n equal 0, 0 over 4 is 0, 1 plus 0, 1, that's right. What about if you have n equal to negative 4, that if it's negative 4 over 4, negative 1 plus 1 is equal to 0, that's right. So that's true. So let's make it clean now. So you can write it in this expression, or you can do the absolute value as we did last time, but don't forget to add 0 otherwise. Of course, these two sentences, you can use the absolute value. I will leave it to you to exercise how you express it as absolute value. All right. That's the triangle one. The last one, we're going to do the sinusoidal, the discrete sinusoid, discrete time sinusoid. What you'll do, let's just have n, and you have the vertical x of n. I will use different color to do the sinusoidal. So that's one velocity and make symmetric one. Let's do another one here, negative. All right, let's now make it discrete. You have 0, 0. I'm just making sample for each unit. I'll be 0 here. Making discrete, or making sequence. All right. Now we don't need the continuous. It was just a guidance for us. All right. So that's the discrete sign. How we express it? Well, to express it, you will just write x of n, the amplitude is equal 1, maximum, so be 1, and then sine, if you remember the continuous one, it was sine omega t. That will be the same, but we want to distinct between both, so we'll make capital omega t, and omega will be the same thing, 2 pi over the period t, but here we're going to call it n. You're asking what is n here. If this is n equals 0, small n equals 0, so the last one here, n is equal capital N. In this example, just let's say that's n equal 1, 2, 3, 4, 5, 6, 7, 8. So n is equal 8. So in this example, you can write it sine, and omega will be 2 pi over 8. See, there's a mistake here. Nobody observe it. It's not t. It's small n. So that's how you write it. Okay. Well, I think there's one left. That was another about the sine function. If you remember the one that we did, the continuous sine function. Sequence. All right. Let's just do the horizontal axis, n, and the vertical axis, and then write the x of n. So how you express x of n, which is equal to the sine function or sine signal n? Well, That's n equals 0, 1, 2, 3, 4, blah, blah, minus 1, minus 2, minus 3, to minus infinity. So when it's positive, n is equal 1, the value will be equal 1, right? When n equal 2, it's equal 1. When n equal 3, when n is positive in general, you're going to have 1. When n is negative, you will have negative 1. You can continue, right? So that's obvious. But there is something here different than the continuous one. What about n equals 0? It's neither positive, neither negative. It takes 0. So just let's write now the sine function. We have 3 values. It's positive 1 when n greater than 0. It's negative 1 when n less than 0. It's equal 0 when n equal 0. That's it. I think it's very easy. All right. Bye.